Hi, welcome to my video on tangents to a circle number 2. Number 1, prove two tangents drawn to a circle from a common point are equal in length. So we'll take our ruler and we have a circle. So what I'm going to do is this circle, I'm going to call this point right here O, which is the center of the circle. I'm going to call this point here P. That's the point that's on the outside of the circle. So two tangents are drawn to a circle. So I'm going to use the ruler. I'm going to draw from P. I'm going to draw a tangent. So a tangent touches at one point. And let's call that A. And we have to draw another tangent. So that would be up here to touch it at one point. Again, this is just approximate. So there's the tangents. So that's a tangent here, AP, and this is the tangent here, and we call this point B. So this is the tangent PB. So we have to prove this. So what I'll have to do is draw a radius from O to B, and also draw a radius from O to A. And I'm going to join up from P to O to create two triangles. Oops. I got two triangles here. Just take that out just for a second, just a little slip there on the drawing of this. And I wanted to do all this from scratch so you can see how proofs are done from the given information. So let's pick the pen up. So we are given, in this proof, we're given that P is exterior to the circle. We're also have that O is the center of the circle. Now, we're also given that PB and PA are tangents at P and PB is at B and PA is at A. Okay. And so we have to prove that PB equals PA. The two tangents are equal in length from this common point, P. So let's do the proof. So we're given that, number 1, we're given that PB and PA are tangents, and O is the center of the circle. So number 1 is given. So what we have by drawing these diagrams, we drew OP and we drew the radii, so that's construction. So let's continue from there. So what we have is that because this is a point of tangency, we have a right angle here, and we have a right angle here. This is the point of tangency. This is the radius, so this is a perpendicular. And so what we have is, we have that this is perpendicular, so we can say that OB is perpendicular to BP, and OA is perpendicular to AP, because the radius is perpendicular to the tangent at the point of tangency. The point of tangency. Okay, let's continue. What we have That means we have PB is equal to PA. Oh no, that's what I got to prove. We have, OB is equal to OA because the radii of a circle are equal. I'm trying to prove these two, and I just wrote it down. So I meant to put the radii here. And we have OP is equal to OP. That's a common side to both triangles. Now, because we have perpendiculars, that means we have angle B and angle A are right angles. That's because of the definition of perpendicular lines. That means we have triangle OBP, OBP, and triangle OAP, make that a triangle now, are the right triangles. That's the definition of right triangles. The right triangles because we have right angles. So that means that the triangle OBP is congruent to triangle OAP because of the hypotenuse leg. The hypotenuse is here, and this leg is the radii is equal. So it looks like we have this is the common side equal to itself. These two radii are equal. So it looks like I have an ASS, but that would be true. But because we have a right angle, then we can use the HL proof. And so that means that we have PB equals PA. And that's CPCTC, corresponding parts of congruent triangles. So these two triangles are congruent, so these two corresponding parts are equal. Corresponding parts of congruent triangles are congruent. So two tangents drawn to a circle from a common point are equal. So let's go and use that property. Right here, PA and PB are tangent at A and B. So these are tangents at A and B. Because they're tangents, then that means that AP is equal to BP. And because these two sides are equal, that means these two angles are equal. So 180 minus 70 equals 110. And these two angles are equal because of isosceles triangle theorem. So 110 divided by 2 is 55. So angle BAP, so angle BAP is 55. So that's 55, and this angle is 55. Which is what we had to prove. Again, the two tangents are equal from a common point, and they form isosceles triangle with the base angles equal. So 55 each. So let's continue to use that property in other examples. Number 3, O is the center of the circle. WY and WH are tangents. So WY and WH are tangents. So these are the point of tangency. If angle W is 50 degrees, so this angle W is 50 degrees, find the measure of this arc YTH, which is a major arc. So because this is the point of tangency and this is the center, so this is perpendicular here forming a 90, and this is a radius and a tangent at the point of tangency, so this is a perpendicular forming a 90. So that means we have 90 and 90, that's 180. So if there's 180 for these two must be 180 adding up to 360. So that means that this angle here, YOH, on this side is 130 degrees. So that means on this side we have 230, because there's 360 degrees around this point. So move all the way around, you get 360. So this is a central angle. So that means this arc is 230. That's one way to do it. Another way is which is the same, similar. If this angle is 130, that means this arc right here is 130, because the central angle made up of two radii and the center of the circle, the intercepts the arc of 130. So this arc out here is, the whole circle is 360. So 360 minus 130 gives you 230. Number 4, O is the center of the circle. A, T, and CT are tangents. And we have AP as a chord. This is the center of the circle. So AP is a chord. The reason I said that means that this is a diameter. So there's a chord going through the center of the circle. So that's a diameter. So let's see if we can let's go around and find what we can, then we'll fit all this in after. And we're told that AC, the arc AC, is 142. So let's take it from here. So we have two tangents coming from a common point T. So this tangent is equal to this one. So what happens? We have an arc. So this central angle here is 142, because the central angle AOC intercepts this arc AC. So this arc and the central angle have the same measure. That means that this radius OA is equal to OC is equal to OP. All these radii are equal in a circle. And because these radii are equal, that means that we have an isosceles triangle with two base angles equal. So again, 180 minus 144 gives us 38. So these two angles add up to 38. So 38 divided by 2 gives me a 19 here and a 19 here. Now we know that this is a tangent, or should know, this is a tangent, and this is a radius meeting at the point of tangency. So this is a 90-degree angle here. So 90 subtract 19 gives us 71. Let's see, 71, right? So this angle here is 71, and this means that this is a right angle here. So this angle here is 71. And let's continue. Now, we can get this angle here. If this is a 90, and this is a 90, this is a quadrilateral. This is 180 here, so these two must be 180. So that means that this angle here must be 38, because 142 and 38 is 180, and these are 180, make up 360. So let's continue here. There are two ways to get this arc and get these angles. One way is, if this is 19, and this is an inscribed angle, so this arc here is 38. PC is 38, because it's twice the inscribed angle. Or the arc is twice the inscribed angle. That's one way to get this arc, PC. Another way is this is 142, so this is supplementary, 180. So this right here is 38. So that means that because these two are equal, that means these angles are equal. So these must add up to 142 in the triangle. So a half of 142 is 71 and 71. So we have everything found. Let's go through and see what we got. CAT, angle CAT, 71. Angle T, 38. Angle P, 71. And the arc PC, right here, this arc, PC is 38. So I went and found everything, and then I fitted it all in here. Okay, let's continue. Now we have number 5. O again is the center of the circle. And we have CA is 8. So CA is 8 units long. And it says the circumference of the circle is 10 pi. TA and VA are tangents. So we got to find the length of VA. VA is a tangent. So this tangent, the length of this tangent, VA, is equal to the length of TA and TV are both tangents, so they're equal in length. So I got to use the circumference of a circle. So the circumference of a circle is 2 pi r. The circumference is 10 pi. So if I divide by 2 pi on each side, r becomes 5. So the radius is 5. So that means that's 5 right there. OC is 5. OT is 5. So we have a right triangle. Reason, this is a tangent. Point of tangent C is T. So OT is perpendicular, so that's a 90-degree angle. So we have a right triangle. So C squared is A squared plus B squared. So let's call this X. AT is X. So the hypotenuse is obviously the right angle. 5 and 8 is 13. A is 5 and B is X. 13 squared, 169. 5 squared is 25. So X squared is 169 minus 25. X squared is 144. X is plus or minus the square root of 144. Let's go up here. X is equal to plus or minus 12. And X can't be negative, so X is 12. So that means that TA is equal to VA. So TA is 12, so that means VA is 12. Again, just using the properties that a tangent and a radius at the point of tangency is a 90, and two tangents from a common point are equal, and using the Moore math. Okay, let's do number 6, the final question in this video. Again, O is the center of the circle. The diameter is 6. AB and CB are tangents. AB and CB are tangents. What quadrilateral is OABC? What I mean by what quadrilateral, what's the name of that quadrilateral? And find the length of HB as a radical in simplest form. Well, let's see what we have. We have tangents, so we have a 90 and a 90, because a tangent and a radius at the point of tangency form a 90-degree angle. And we have, these are two tangents from a common point, so these two tangents are equal. But that, it says that OA, or AO, is equal to AB. So these two are equal because they're common tangents. These two are equal because they're given. And we have, notice, we have right angles, and we have 3 sides equal. So that means this must be a rectangle. These triangles are AOB and COB are congruent. Why? Because OC is equal to OA. OC and OA are equal because they're radii. We have all 4 sides equal, which means we have a rectangle. And because all sides are equal, no, all sides equal means we have a rhombus. because we have all sides equal and we have a 90-degree angle, this is a square. So we have all sides equal and we have a 90-degree angle. So we have a rhombus with a square. Rhombus with a right angle is a square. Now we have to find the length of HP. So the diameter is 6. So the diameter is twice the radius. That means 6 is twice the radius. Divide by 2, the radius must be 3. So if the radius is 3, that's 3 there, and that's 3 there, and that's 3 there. Okay, how do we get the length of this side? Well, this is a square, so this is 3, and this is 3. All the sides are the same. And because we have a square, so we have the triangle. I'll redraw that triangle now so you can see it. So we got a right angle, we got a 3 and a 3. So this is A, and that's an O and a B. Because these are equal, again, we have a right triangle with two sides equal. So this is a 45 right triangle. If two sides are equal, two angles are equal. So that means that's n, and that's n, and that's n root 2. So that means if n is 3, this side is 3 root 2. So OB is 3 root 2. Now we could also find this length by doing c squared is 3 squared plus 3 squared, and that works out to be 3 root 2 when you finish it. So OB is OH plus HB. So OB is 3 root 2. OH is 3. So HB must be 3 root 2 minus 3. That's a right angle in simplest form. Again, we have a right angle at the point of tangency. We got the tangent from a common point equal, and we have a square here because all the radii are equal, and these two sides are equal, so it's a square. And again, just more math working. Notice I worked the special right triangles and the properties together this time, and it was a 45 right triangle. And we'll come to the end. If you like my video, click the like button. If you want to be a subscriber to the channel, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video was of some help to you. Bye-bye.